In this video, we're going to work on this Leetcode challenge, longest common prefix, question 14. I started with the easy challenge because I don't want my soul to get crushed. Because we all know how a Leetcode easy question goes. It can take me like an hour, and I still can't figure it out. But let's go ahead and take a look. So write a function to figure out the longest common prefix starting amongst an array of strings. If there is no common prefix, return an empty string. Okay. Seems so it's not that complicated. Okay, take it back. But the question's not that complicated, right? So it's just return the longest, common prefix. So in this case, flower, flow, flight, they all have FL. That's a common one, right? Dog, race, car, they don't have any common ones. Okay. So what we might do is we might need to check all of them. Right? So we might need to check all of them. Let me also open up an incognito window. Perfect. Okay. So let's go ahead and loop through word, right? So how should we do this? We kind of want to find the smallest thing, right? Well, I want to find the smallest what's that? So we want to find the smallest stir in stirs, and then we loop through that many times and just check for commonalities. I think that's how we do it. Actually, no. Okay, let's see if I can let's define new helper function. So let's just say smallest stir. Right, so that will give you, so that would take in a stir, which is a stir. And it will return an int, like so. So in here, no, actually no, we'll take a list of, so we'll take stirs, like so. So this will find the smallest. So let's talk about the logic, right? So we have a for loop, right? Let's say we have this. Right, so I might loop through all of them. Yeah. No. Well. Oh god. So let's see. What we might do is we loop through. We find the smallest. Well, if we find the smallest, right? So we can say maybe a while true. Let's say a while loop, right? So because I need to figure out a way to check the if statement, to write the if statements. So just check, I guess, one by one, maybe. Oh, no, we're not going to use a for loop. We're going to, well, not a while loop. We're going to use a for loop. Yeah, I'm going to say for I in range of the smallest, right? The smallest lengths. I know my handwriting is so bad. So s, right, that's going to be the smallest. In this case, s is going to be equals to 4. Right? And then we loop through the word. Right? In word. Right? And then we can say, what if w bracket I equals, so okay, so in here we're going to have a correct one, right? Correct, and then we'll set the correct here, And that's where we set the value every time, and then enter the for loop. If everything works, right, then we can say if wi, so that needs to be indented. If wi equals what? Equals can't read my correct, right? Equals correct. Then okay, now here's the thing. If it doesn't equals to correct, it's just gonna break the loop or figure some way to make the loop stop, right? So we can say stop. Just stop. So of course it's just pseudocode, and then we can have a prefix. P is an empty string, and then we can just say P plus equals. Right. Okay. Yeah, I think it's the most efficient way I can came up with. So let's get started. So well, the first task is to find the smallest stir length, right? So you can say for s in stirs, now smallest equals float infinity, because that's the biggest, right? Where we can set it to arbitrarily big number, like more than 200. So here we can say something like, I don't know, if length of s is less than smallest equals length of s, and then return length of s. I don't care what word it is, I just care the smallest length. Alright, so if length of s, so let's say smallest, right? Smallest equals find self.find smallest stirs. If smallest is 0, then we just return an empty string. So we can say prefix equals that. All right. Okay. Return prefix. Otherwise, we can cut. We can basically do what we did here, right? So we can say for I in range of smallest, for s in range, for s in source. If so, we also need to say the correct one, which will actually simplify this. Again, go here. Correct equals. Okay, never mind. We actually need to do this as well. I need to return the word. I don't need this. Word, okay, well, I need to make it greater than 200. Right, I need to make it greater than 200. I probably overcomplicated so much. Yeah, equals if length of smallest. Now the correct one will be smallest bracket I. No, we can just say char, right? If s bracket is, no, it need to be I. If s bracket I equals smallest bracket I. Right, I'm worried it might not pass a timer requirement, but I sure hope it passes. Now I can just say break. Right equals false. Alright, so it's like a flag. If we can just say, yeah, if not run. Otherwise, we can say prefix. Okay. Prefix as bracket I. Yeah, prefix. Let's see. Probably not gonna work. Oh. Well, it doesn't matter. Honestly, we can just say change equals false, which I definitely complicated. Yeah, because the reason is I don't want to keep track of two variables, but I mean, looks like we're needing. I want to work though. Let's see. Oh yeah. So it need to be the lengths. All right. Well, time to see if it's gonna pass a time complexity or whatever. Well, we did. Hey, look, it's faster than 58.60. Yay, some faster majority of people. Oh, look, I use so much less memory. Yay, I'm so happy. All right, so this is a solution, right? So again, what we did here is we find the smallest string, right? And then we run it, and then we said, okay, yeah, if the smallest is 0, then just gonna return the empty prefix. Now I have this flag check here, right? We loop through the smallest. For instance, do that, right? Loops through every string, so the smallest. If the smallest is, whatever, then return prefix. Now we're gonna break the loop if it's, the prefix doesn't match anymore, and then if everything matches, then we're just gonna add it to SI. So very simple. The timing complexity, I'm really bad at big O's, whatever. Probably, I don't know, length of smallest times the length of, prefix. Yeah. All right. So it's probably linear runtime. I don't know. I don't know what I'm talking about. But don't trust me. But yeah, now we did that. I think we have time. Why don't we try another one? And here's my ugly pseudocode. Look at it. All right. You don't think Leetcode is the best way to interview candidates? Well, cool for you. All right. So let's go ahead and have another easy one because I don't want my soul to get crushed. Huh. Sure, whatever. All right. Easy. Roman to integer. I don't like valid parenthesis. Merge term. You know what? May as well look at this one. This one sounds interesting. Employees earning more than their managers. Only if it happens in real life. Oh, it's SQL. Huh. I'm not going to do SQL today. I'm just going to do Python. So let me also sort by Python. Easy. Let's see if this is. Alright, given an array nums of size n, return the majority element. The majority element appears more than n divided by 2 times. You may assume the majority element always exists in an array. Oh, it doesn't sound too hard. Oh, look at this big number though. Whenever they use scientific notation, you know, something's not good. N equals to nums length, sure, whatever. Okay, so majority elements. Honestly, I will sort the array first. And then just cut in half. Right? Well, because here's the thing. Now what I can do is see how okay, that's bad. So let me paste this. So implement a sorting algorithm. I hate sorting algorithm. We could do what's that called, bubble sort, the most inefficient algorithm. So let me just grab a sorting algorithm. I know I'm gonna copy some code from Wikipedia again. I'm really bad at it now, right? Okay. Quick sort. I think it is the same. I'm really bad at these algorithm stuff. All right. Okay, so that does stuff. You know what? Let me just grab bubble sort. I know bubble sort is probably the simplest. So I do want to try to interpret what's happening. Okay. So basically, we sort the array. Anyhow, right? We sort the array. And basically what happens is then we sort the array that's 1, 1, 1, 2, 2, 2, 2. Right? It has to appear more than n divided by 2 times. So the length is 7. 7 divided by 2 plus 1. That will be, what would that be in Python? Let's grab a Python interpreter. Yeah, what sort of simplest looks like. Sure, whatever. Okay, perfect. Right, so we do the mass evaluation there. Okay, because it should always round down. Now, if that's true, right? So then basically we split it at index number 4. 0, 1, 2, 3. No, we can't split it. I think, what is it now for? 0, 1, 2, 3, 4. So you need to appear basically more than 4 times. So I always split at half point. So split it between 2 and 3. Right? This is index. And then something and then I check for majority, right? Basically, well, for this one, it's whichever side is, well, yeah, for whichever side is bigger, right? Or I don't know. Okay, let's define a sort algorithm. All right, I copied from Wikipedia, wherever this website is. Geeks for Geeks, yeah. Okay. Yep, that's a bubble sort. Okay, so one was to say I would remotely implement a sorting algorithm. Okay, so let's call bubble sort all nums. Let's just print. Honestly, I think the logic will work, but the thing will be the runtime. Really thank you. Okay. Okay, so it's not defined. Well, that's really unfortunate, but I'll go ahead to define it like so. Yeah, doesn't sort in place. Yeah, good. So we split it. So we split it. So split index. That will be length of nums divided by 2. And then we need to turn it into an integer. That's where we want to split you at. No, how to split list? No, that's not what I want to do. Oh, no, never mind. No, split at index. Oh, right. Yeah, I didn't do split for a while. Okay, so right. What are we gonna say? Okay, here's the thing. I'm going to make a couple assumptions. Right, equals 1, and then I just return nums 0. Else elif length of nums equals 2. Right, because I can just return nums 0. That will be fine. And then now I can just split. So I'm going to say left is 0, 2. The split index. And right is split index to the end. Say nums. No, oh my god, I don't know what I'm thinking. Yeah, I need a split list. Oh, never mind. This should also work. Yeah, so, okay. Yeah, I don't know what I'm thinking about right now. But, okay. So, here's what we'll do. Here's my logic, right? If left, the smallest number in the left is also equals to the smallest on the right. It's greater than length on the right, and just return left bracket 0. Elif length on the right is greater than length on the left. Right bracket 0. Else, if they are the equal lengths, which hypothetically should never happen. All right, let's see it. Yeah, it should never be equal lengths. It can't be equal lengths. Probably run out of time. I'm doing the brute force way. What am I? I think I'm doing a smarter way. All right, whatever. Else. Well, here's what we're gonna do. If left 0 equals left -1, return. Yeah, time limit exceeded. Okay, I'm gonna try faster sorting algorithm. Quick sort. All right, I'm gonna borrow the code. Oh no. It did not. Okay. Well, it did the recursive way. Not the best way. That works, but alright. Wait, how is it getting called? Okay, so all we need to do is quick sort. Is it also in place? It is also in place, alright. Nums 0 length of nums -1. Alright, let's see how quick the quick sort is. Not quick. Okay. Oh, these two are not supposed to be. So outside of for loop. Okay. Let me link this. Alright, let's run the code. Okay. Yep. Alright. 63 milliseconds, not even that faster. Alright, let's see if quick sort's faster. I think quick sort is probably one of the quickest sorting algorithms. times exceeded. I'm not sure why would it. It's already sorted. Well, if any of you know how to fix it, feel free to comment down below. But that's all I'm gonna have for this video. So yeah, thank you for watching this video. Any question or comment, feel free to comment down below. But as always, stay safe and have a great rest of your day. That was me, out.